weight loss or present weight, and then finalize. We have to check whether what's happened in the present and the previous measured record. That is the paired variable mainly, right? In this case here, before weight is given, after weight is given, right? Before weight is given, after weight is given. So in this paired variable, when we can choose the group first and the second group also do the same. Both are same group, same members, same guys. No more change in between these members, right? Before and after the measurement should be taken. In this example, 1, 2, 3, 4, 5, 6, 7, 8. 8 members. So before and after the diet program, the measurement is going on, right? So what is our null hypothesis? What's our null hypothesis? What do you feel? What's our null hypothesis? So what's our null hypothesis? Before and after. Before and after. There is no more weight loss. There is no more weight loss. That means the before weight minus after weight, the weight loss approximately equal to 0. So the null hypothesis is equal to, check whether the value is equal to 0 or right? Say in this way, we can implement this this practice. Now we can enter the data in Spss. Could you see the side-by-side screen? Could you see the side-by-side screen?
Yes, sir.
Okay. Right. Now, the first variable name before, the variable type is numeric, and the size is 3. No more decimal, right? No more decimal, right? And you can check missing values. That's not a problem. Scale, right? Measuring scale. So the second variable after that should be the same. Width is equal to 3. Decimal no need, 0 decimal. And now only 2 variables is enough to do this paired sample t-test. So now I can change the datasheet view. In this datasheet view, first one 162, second one 170, third one 184, fourth one 164, fifth one 172, sixth one 176, 159, and 170, right? After the values 168, 136, 147, 159, 143, 161, 143, and 145. Is it okay? Up to this end, okay? If you have any problem up to this? Hello, 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 hello. Shall I continue?
Yes.
Okay.
Yes,
Right.
sir.
Right. So now we can analyze. So analyze, compare means. Compare means we can compare the means, paired sample t-test, right? First, before, choose the before is the variable 1. Choose the before is the first variable. And select the after, move it, that is the variable 2. Right? In this way, you can check whether not only one pair, you can check 2, 3, 4 number of pairs, right? That's all. If you can put before and after, then in the option 95% confident interval, and bootstrap is also nothing, right? That's all. So click OK. Say number of sample measured here 8, and standard deviation and standard error. Paired sample correlation 0.675. That means it has good correlation between comparably moderate correlation between the before and after samples. And here the significant value is 0.008. So the value the alpha is 0.008. This value is less than 0.05. That means, so in 95% confident interval, we can simply reject the null hypothesis, because null hypothesis says there is no weight loss before and after measuring the weights. So that means before and after, if you can deduct before and after, or after and before, the weight loss is equal to 0. That is the null hypothesis. Alternative hypothesis, these weight difference not equal to 0. So in this case, alpha less than 0.05, we can reject the null hypothesis. We can accept the alternative hypothesis. That means the diet program is working successfully, right? The diet program is working successfully. So there is a weight loss between before and after the weights. Could you understand what I say? If I want to repeat it again, or if I want to mark the point again, if I want to press anything in this point, let me know.
So can you please explain these tables again in the
So in this table, actually nothing. So the mean value before is 169.63, after 150.25. It means, so before average weight is 169 and after average weight is equal to 150. So before and after weight loss is going on. So the standard deviation, the before standard deviation is approximately less than the after the standard deviation. So the correlation between the first and second is equal to minus 1.77. So negative correlation. So here mean value 19.379. This mean value means, this mean value is before minus after. The deduction of before minus after, 169.63 minus 150.25. That is the mean value for before and after. Standard deviation for, if you can subtract the before and after, the standard deviation is closer to 14.784. So the lower end and upper end. So in between the gap, these are the gaps is available. T-test value and degrees of freedom is 7, 8 minus 1. And the significant value is equal to 0.008. This value is less than 0.05. When we are checking 95% confident interval, if the alpha is equal to 0.05. So the test value less than alpha 0.05, then we can reject the null hypothesis. The reject the null hypothesis means reject the null hypothesis. Reject the null hypothesis means reject the null hypothesis means there is some significant difference between the before and after the test. So we can reject, there is no weight loss. We can reject, we can accept, there is a weight loss. There is a weight loss. Right? So if you want to get the results, I can repeat it again. So enter the data and analyze, compare means. So in this case also, in this paired sample case also, we check whether what's happened for the weight. So right, so compare means we can check whether what about the average mean value. So compare means and then go to paired sample t-test, right? Go to paired sample t-test. So in this table we have only two variables, before and after. If you have more than two variables, then there is no problem. You can choose what are the variables if you want to test, or if you use to test. What are the variables we want to check? So before and after. So in this table, sometimes we can put one serial number, 1, 2, 3, 4, up to 8. How many participants participate for this experiment? So there are three variables may be displayed. So serial number, before, after, but before and after is the main variable to check whether the paired sample. So only we can move the before and after variable to the checking variable. Then the first variable we can move like this here. If I want to move here before, select the before and move it. So before will come here. If the after is not available, then select the after and move it. After will come to take the location. So what do you want? You can move and then click OK. That's all. Right? Hello. Okay. Shall I repeat it again? Or no need?
So after finishing this, we write the significant value is less than 0.05. So we reject the null hypothesis. That is all right.
Yeah, that's all. So the actual thing is the value 0.008 less than 0.05. So in this significant value, the value is less than 0.05. Due to that, we can reject our null hypothesis. Null hypothesis, what is the null hypothesis? Null hypothesis says there is no difference between before and after test, right? So that means before minus after value is equal to 0. Before minus after value is equal to 0. So that is rejected. Why we reject that one? The value is less than. So then automatically we can accept the alternative hypothesis. Alternative hypothesis says what? Say this value have some different, right? So the before and after the test, we have some deviation between before and after the test. But in our mean value checkup, here, the before mean value is 169.63. After the mean value is equal to 150.25. So definitely we can say, due to this diet program, there should be a clear-cut weight loss we can observe. Why? The mean value comes down. Mean value comes down. If you don't have any mean value about this, then you can't say, you can reject the null hypothesis and accept the alternative hypothesis. You can't say weight loss or weight increase. But in this case, you can clear cut, you can say the weight should be decreased. Why? After the mean value came down. Is it okay? Is it okay?
Yes, sir.
If anyone have any problem, let me know. Okay. Hello. Okay, shall we move the next one, or we can try to work with some other question? What do you feel? Shall we do another exercise, or is it enough? Hello. Choice is yours. What shall I do? Shall I do another exercise, or is it enough? Hello.
Enough, sir. Move to.
It's clear. So if you want to practice another exercise in before and after, or no need? We'll see another exercise. Right? Okay. So Excel actually, what is the thing? So a clinic provides a program to help their client lose weight and ask a consumer agency to investigate the effectiveness of the program. The agency takes a sample of 15 people, weighting each person in the sample before the program begins, and 3 months later to produce the table in figure 2, determine whether the program is effective or not, right? So could you see the side-by-side screen?
Yes. Yes, sir.
Okay. In the variable view, so in this case, there are 3 variables. The first one is person, So the person is numeric. It's 2 digits is enough, and the decimal place is right, and the second one before is equal to 3 decimal, and sorry, 3 digits, no more decimal, after numeric, and that one is also with 3. Right. So now we can save the data, enter the data sheet view. 1, here 210, 197. 2, 205, 195. 3, 193, 191. 4, 182, 174. 5, 259, 236. 6, 239, 226. 7, 164, 157. 8, 197, 196. So 9 samples, 222 and 201. So the 10th sample, 211 and 196. 11 sample, 187 and 181. 187, 181. The 12th sample, 175, 164. 13, 186, 181. 14 sample, 243, 229. So the 15 one is 246, 231, right? So in this way, when we are entering the data and go to the analysis menu, compare means, go to the analysis menu, compare means, so check whether paired sample t-test. Here, the person is no need for this test, only before and after is enough, right? Before and after is enough. So I can move before and after here and then click OK. Here, the before value is 207.93. After the mean is 196.93. So there is a mean difference is available. So the significant value, the correlation between these two is 0.983, high correlation. Here, the significant value is equal to 0.000. So this value is less than 0.05. Then we can reject the null hypothesis. There is a clear-cut mean difference is available. Due to that, we can say in this diet program or in this particular survey, we can simply say there is a very impact in the weight loss, right? Because before and after the test value came down. Is it okay? Hello, 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 hello. Okay, 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 okay.
Okay.
Shall we move? Shall we move? So up to this, one sample t-test is over, two sample paired sample, and unequal variance, equal variance, right? So two sample t-test is over, right? Then now we can move. Now we can move to Anova. Anova means analysis of variance. This example teaches you how to perform a single factor ANOVA, right? In Excel or SPSS, whatever. A single factor or one-way ANOVA is used to test the null hypothesis that the means of several population are equal. So in these terms is very important. In a single factor or one-way ANOVA is used to test the null hypothesis that the mean of several population are equal. So if they can give three different population group, then we can check the null hypothesis. All these three groups are equal or not equal. Not equal means at least one of these group is deviated from other, then we can reject the null hypothesis. But in the ANOVA test, we can't say which group is deviated from other two. Only we can say that these three mean value are not equal, right? These three mean value are not equal. So that is the first thing. Second one, in ANOVA, so only we can check the mean value, look like t-test, right? Look like t-test, right? So in ANOVA also, we check whether the mean value of that particular group is equal or not equal. So due to that, there is no more restriction. Each and every values in this group not equal, not equal. So the first group contain 10 members, second group contain 8 members, third group contain 5 members. We don't have the problem because we are check whether the mean value of the first group, mean value of the second group, mean value of the third group. Is it clear what I try to say? Hello? 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 Hello?
Clear.
Okay. Okay. Otherwise, it's look like broadcasting, no? The one-way analysis of variance is used to test the claim that 3 or more population means are equal. This is an extension of two independent sample t-test. Actually, in the t-test, in two independent sample t-tests, what's the null hypothesis? Mu1 is equal to mu2, right? That is one t-test. So if you can check mu2 is equal to mu3, then in this ANOVA, it's look like two different t Give me 1 minute. Someone is coming. 1 minute. Okay, so one sample t-test means actually two independent sample t-test, right? Say the response variable is the variable you are comparing. The factor variable is the categorical variable being used to define the group, right? The one way is because each value is classified in exactly one way. So conditions and assumption or condition or assumption in one sample t-test or one way ANOVA, the data are randomly sampled or the data are selected randomly. The variance of each samples are assumed equal. So no more variance in between this group. The residuals are normally distributed, right? The null hypothesis, so the null hypothesis is that at least one of these means is different, right? So the null hypothesis anyway in ANOVA, you can check whether mu1 is equal to mu2 is equal to mu3 or mu4, whatever, how many groups is possible. So that much of mean groups is equal. That is the null hypothesis. Alternative hypothesis, at least one of these groups is deviated from the other. The alternative hypothesis is that at least one of the mean is different, right? So I can roughly go through the theory part of one-way ANOVA. Now I will come to the exercise. The statistics classroom is divided into 3 rows, front, middle, and back, right? The statistics classroom is divided into 3 rows, front, middle, and back. Back means balcony, middle means middle, front means gallery, right? Gallery students, balcony students, and middle students, right? The instructor noted that the further the students were from him, who is keep more distance from instructor, the more likely they were to miss class or use an instant messenger during class, right? So he wanted to see if the student further away did worse on the exam, right? So this is the conceptual thing. What about the performance of the front row, middle row, and the last bench students, right? What about the marks deviation from front, middle, and last bench students? The ANOVA doesn't test that one mean is less than another. Actually, in this result, we can't say one mean is lesser than the other. Only we can say all means are equal or someone is deviated from the other, right? Say this is the ANOVA example. The front row we can choose 2, 4, 6, 7 students. Middle row we can choose 9 students. Back row we can choose 8 students. Why I gave this example? Because when we are choosing one-way ANOVA, no need to check the numbers of the students are equal, because we are checked whether the mean value is equal or not. That is the main thing, right? So due to that, we can assume the different number of samples, right? So enter this sample in SPSS. So go to the file, new, right? In this variable view, first one front variable, right? Could you see side by side screen? Hello?
Yes.
Okay. Say the front, no more decimal place. Middle, no more decimal. So, and back, no more decimal, right? Okay. So change the data sheet view, front, middle, back. Here 82, 83, 97, 55, 67, 53, and middle row 83, 78, 68, 61, 77, 54, 69, 51, 63. $38, 59, 55, 66, 45, 52, 52, 61. Is it okay? Hello, is it okay? Is it okay? Right. Analysis, compare means one way Anova, one way Anova. In these three groups, we want to check all three groups. Sorry. In this t-test and Anova, all the data when we are entering here, the same thing. Here one is group, group variable. Another one is grouping variable. Grouping variable means 1, 2, 3, or we can say marks, right? Here in this variable, when we are press 1, that means front, add. If you are press 2, that means middle, add. If you are entering 3, that means back, right? Say when you are show the data is show in Excel or in your table, and when you are entering the data in your SPSS, it should be different, right? It should be different. First one, now we want to enter the data, same data, but different pattern. First one, group, the group value is 82. Second one, 83. That one is also 1, right? 1. It should be 97, 93, 55, 67, 53, right? And 83. Right, 78, 68, 61, 77, 54, 69, 51, 63, 3 means 38, 59, 55, 66, 45, 52, 52, 61, right? 3, right? Are you agree? We can enter the data, look like this. Say, first we can take the first 7 rows. So these rows mention the front group. There are 7, in this front group, only 7 data. So in the middle group, the second one, so only 9 data. And the third one, there is 8 data, right? So when we can change here, then the here, when we are enter the data in SPSS, if I am enter 1, then it should be displayed as front. If you enter 2, it should be displayed as middle. If you enter 3, it should be displayed that is the back. So that's why I check whether what's the thing I couldn't find. Okay, right? Analysis. Compare means one way Anova, right? What is the dependent variable? What is the dependent list and what is the factor variable? What is the grouping variable and what is the dependent list, right? Say marks, we can try to find the marks, depend on the factor variable group, right? Here, nothing. If you want to check post-hoc test, then only you can go this way, right? Otherwise, option. In this option, you can describe descriptive statistics or fixed random effect, homogeneity of variance, right? If you want, take the mean plot. That's all. Then click OK. Here, if you can check whether, then so the descriptive statistics should be displayed front, middle, back. There are 7, 9, 8, and the mean, standard deviation, standard error, lower end, upper end, minimum, maximum, everything should be described in the descriptive statistics. It's not the Anova. When I go to pick the descriptive statistics describe these things, right? Test homogeneity of variance. Here, the homogeneity of variance is also accepted. And then between the groups and within the groups value, the significant is less than 0.09. So then we can reject the null hypothesis, accept the alternative hypothesis. So say this is the mean plot. What's happened for the marks? So frontliners marks are high, middle group marks are middle, and back group marks are comparably very low marks. So all these three mean values, we can simply come to the conclusion. So in these three groups, so we can reject the null hypothesis. The mean value is deviated. So the average marks of the student between the front, middle, back row should be deviated, but we can't say which is deviated from which one. Is it okay? Hello?
Yes, sir.
Hello, 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 hello. Okay. So now up to this section, one sample t-test, two sample t-test, paired sample t-test, one-way ANOVA is over. So no problem. Don't worry about the results. When you are selecting this one and click OK, automatically output window should be give these results. When you select everything and click OK, automatically the output pop-up menu display. Right? Don't worry, the output results is automatically pop up. Right? There are two screens. There are two screens here. This is our datasheet view. This one is the output screen. Output screen is also should be there. Okay. If you have any problem, any clarification, if you want anything about this. So thank you, be patient. What do you feel? Is it enough for one-way ANOVA, or I want to repeat some other example for ANOVA? No need. ANOVA is over. Okay. Okay, it's up to you. Let me pass the message. So in this case, go to the analysis, compare means, right? Compare means and one-way ANOVA, right? Compare means and one-way ANOVA. Here, the list should be displayed. I want to analysis, compare means one-way ANOVA. Say right here, marks is the dependent variable, right? We can try to find the marks. The factor variable is the grouping variable. Who is the front liner? Who is the middle liner? Who is the backend users? That's all. So in this option menu, I will go and tick descriptive statistics, homogeneity of variance, and mean plot. That's all. Click OK. Click OK. That's all. So everything should be displayed. Right? If you have any problem, anything about this?
In this variable view for front, middle, back bencher, we can in the type numeric type, can we type the string and type their
No.
front, middle, back?
No. If you type that one in a numeric, if you type that one in a numeric, then you can't categorize, right? You can't categorize, right? So put it in a categorical way, right? Put it in a categorical order. Say in analysis compare means here, this is the categorical order. You can categorize. So if you can put string, you have a problem to categorize. So put it numeric and categorize. The 1 means this, 2 means this. Then the categorical variable should be displayed. You can categorize. Right? In this symbol, there are three rings comes to couple. That is the categorical variable, right? So if anyone, you have laptop or desktop, please try to work. In the next class, I will repeat it again, not for this example. I will come another example. Or in your class exercise, if you have any other question, if you have, then we can practice that question also. I have no issue, right? So we will meet in the next class. Okay, thank you. Be patient. Shall I stop? Shall I close? Hello.
Yes, sir.
Yes, sir.
Okay.